Okay, so hopefully you didn't have any problems with the problems from page 641, 1 through 21, 4 through 21, I think you did. Let me just do a couple of those for you. Number 12 says P of 8, 2. So P of 8, 2, you can write it like this, or you can write it like this. The number of permutations of 8 things taken 2 at a time. Again, order matters, so it's permutations for some reason, all right? So the formula for permutations is the number of n things taken order at a time, n factorial over n minus r factorial. While I'm at it, let me write down the other one. Combinations, n things taken order at a time is n factorial over n minus r factorial times r factorial. So there's this one extra r factorial in the combination ones. That's why when you doing combinations or permutations, you get more permutations when order is important. You get more possibilities here. But this is permutation, so it's 8 factorial over 8 minus 2 factorial. So this should have been 8 factorial over 6 factorial. And the easiest way to simplify that, instead of going all the way down to 6, 5, 4, 3, 2, 6, 5, 4, 3, 2, and divide them all out like that, you just stop right there and just say, okay, from here on down, it's exactly the same at the top as it is at the bottom. And so 8 times 7 then is 56, okay? So that's what you should have done for number 12. So just check these on your own there. You still have your paper. You took a picture of it. You turned it in to me. Check that and make sure that you got those right. At the end there, they multiply some, 12, 4, and 8, 3. Okay, so you're multiplying 2 things together. Combinations of 12 things taken 4 at a time, and the combination of 8 things taken 3 at a time, and for some reason they have some kind of situation where you multiply these 2 together, so it's no big deal. It's just a multiplication problem of 2 different combinations. So combinations of 12 things taken 4 at a time is 12 factorial over 12 minus 4 factorial times 4 factorial. All right, times, and then 8 things taken 3 at a time is 8 factorial over 8 minus 3. So hopefully, after you've done all these, that you got good at remembering what the formulas were, because you just do them over and over again, and the formulas are not that complicated, so you should be able to have those memorized, even though you weren't really trying to, just by doing it over and over again. Okay? And so you simplify this by saying that's 12 factorial over 12 minus 4 is 8 factorial times 4 factorial times, and this is 8 factorial over 5 factorial times 3 factorial. All right, so it's just a whole bunch of multiplication, and you got fractions, and so you want to simplify. And so the first thing I notice is there's an 8 factorial here and here. They don't have to be right over each other. It's all multiplied together, the way you multiply fractions, right? Numerator times numerator, denominator times denominator. You multiply straight across, and so you can divide out anything over here with this over here. And now I'm looking for an easy way to simplify this, and I don't see it. So I'm going to go 12 times 11 times 10 times, I'm going to go all the way down to 5, I guess, times 9 times 8 times 7 times 6 times 5 factorial. Okay, unfortunately, it's not true that like 3 times 3 factorial times 4 factorial is not 12 factorial, right? 4 factorial is 4 times 3 times 2, and 3 factorial is just 3 times 2. So it's not the same as 12 times 11 times 10 all the way down like that. But you can stop at 5 factorial here because we have one at the bottom that we want to divide out. And then we still have to deal with 4 times 3 times 2 times, and then 3 times 2. All right, so you just got to grind this out a little bit. Divide out the 4 factorials. 3 times 2 is 6, so you can cancel those out. 4 times 3 is 12, so that goes away. And then 2, you can say 2 goes into the 8 and leaves a 4 there. And so at the end of the day, you have 11 times 10 times 9 times 4 times 7. And just multiply that out, whatever that comes out to be. That's your final answer. No point in me doing that for you. Okay? The thing today, we're going to go on with the rest of these problems on that page, on page 641. Let's do the assignment today will be 22 through 32. So go back and, spelled 32 wrong. Go back and look at the previous video to see what these problems are. Or would it be easier for me to hold the book up again and show you again so you don't have to go back and look at it? Let me try that. So page 641, 22 through 32. Let me see if I can do this one more time and try to, so that's on this page over here, yep. And I'll try to hold it still enough once I get it focused. Okay, I can't tell. Just go back and watch it, I'll see how it came out. If you can't read it, then go back and look at the previous video. So let me just work one of these for you though, to get you started. It says, determine whether each situation involves permutation and combination, and then find the number of possibilities. All right, so the winner and the first, second, and third runner-up in a contest of 10 finalists. All right, so we got a beauty pageant of some. There's 10 people in it, and we want to pick out the winner, first runner-up, second runner-up, third runner-up. So we want to pick out 4 people. Okay, so the question that you have to ask yourself is, does order matter? Does it matter who gets first place, who gets second place, who gets third place, who gets fourth place? Or is it just a matter of just any 4 people will do? And the answer is, of course it matters. If you ask the girls, if it's a beauty pageant, it absolutely matters. You don't just pick 4 girls, the 4 prettiest girls, and the 6 ugliest ones over here. You got to pick who's the prettiest one of them all, and say she's the winner, and the next one is the first runner-up, and so forth. So of course it matters, and therefore we're talking about permutations. All right, the permutation of 10 things taken 4 at a time is equal to, and you go 10 factorial over 10 minus 4 factorial. So it's 10 factorial over 6 factorial, 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Divide those out, 10 times 9 times 8 times 7. So whatever this, multiply those out, and whatever that comes out to be, that's the number of different ways that you could pick a winner, a first runner-up, second runner-up, and a third runner-up. Okay, so that's definitely permutations there, because order definitely does matter. Looking down the way a little bit, how about the last one there, 32? How many ways can a 5 members of a 100, okay, you got the U.S. Senate, be chosen to be put on a committee? Okay, so number 32, so I'll get you started on this too. Let you do the rest of them. 32 says, all right, you have the U.S. Senate. There's 100 people in the Senate. We want to choose a committee of 5 people. We don't care whether Democrats, Republicans, or Independents or what. We just want to choose 5 people. They're on a committee. We're not choosing the chairman of the committee. We're not choosing the head of the committee. We're not choosing a sub-chair. We're just choosing 5 people to be on committee. Order doesn't matter. It doesn't matter who you chose first. It doesn't matter who's the tallest. None of that matters. The only thing that matters is who are the 5 people you're going to choose on the committee. Therefore, since order doesn't matter, you're talking about combinations. 100 guys chosen 5 at a time. All right? So work those problems, turn those in, go back and check any old work that you hadn't finished yet, and make sure that you got it all done. See you next time.